About solving equations with variables on both sides again. And this is part 2. So, again, we've got an equation with variables on both sides. If we take a look at number 1, it's 11 plus 3x minus 7 equals 6x plus 5 minus 3x. Our first step here is going to be to simplify, because if you look here on the left, I've got 11 and I've got a negative 7. I want to simplify that. It's just on the left of my equals, I'm just going to add those together. And on the right, I've got a 6x and I've got my minus 3x. So I want to combine those as well. So I've done that. Look, my line didn't quite work out, but that's okay. So 11 minus 7, that's where I got my positive 4. And then 6x minus 3x, that's where I got my 3x. So now my equation is simplified. I've got 4 plus 3x equals 3x plus 5. Going back to what we learned the other day, I want to get my variables together. So I'm going to subtract 3x to both sides. That way it should eliminate from the left. So, but this funny thing happens, right? Because I've got 3x minus 3x on the left. That goes away. I've also got 3x minus 3x on the right, and that's going to go away as well. So I'm left with this statement that 4 equals 5. That doesn't make sense. 4 doesn't equal 5. So this is an equation with variables on both sides where we don't get an easy answer. Instead, since we end up with this false statement, let's go ahead and let's just say doesn't equal 5. X doesn't have a solution. So sometimes X doesn't have an answer, and you'll know that because you'll end up with something like 4 equals 5 that we just know is false. So that's one of the funny answers that can happen here. Let's take a look at our other funny examples. Here's problem number 2. So problem number 2, I've got 6x plus 5 minus 2x equals 4 plus 4x plus 1. So again, on the left, I've got a 6x, I've got a negative 2x. I'm going to combine those. And on the right, I've got a positive 4 and a positive 1. So I'm just combining my like terms. So on the left, 6x minus 2x gives me 4x, so that plus 5. On the right, my 4 plus 1 gives me a 5 plus 4x. So some of you guys might be realizing already, 4x plus 5, that's the same as 5 plus 4x. We're going to pretend like it's a regular equation though. I want to get my 4x together on one side of my equals. So I'm going to go ahead and I'm going to try to subtract it, see what happens. But when I subtract my 4x, again, funny thing happens. Cancels on the left, and it cancels on the right. So it leaves me with this statement that 5 equals 5. Well, 5 always equals 5, right? It's true. When that happens, we say that x could be any real number. There's an infinite number of solutions. I could choose any number in the world. I could choose 0, I could choose 3 halves, I could choose negative 1,000. And if I plugged it in to this original equation, I would get a true statement. So if I end up with something like 5 equals 5, which is always true, then I have an infinite number of solutions. It's kind of funny. We'll get used to it. One more example. I've got problem number 3. 3 times the quantity x plus 2 minus 7 equals 2x plus 2 plus x minus 3. So whenever I have parentheses, I want to distribute first. It's always my first thing. Then after that, I'm going to start combining my like terms. So I distributed, I get 3x plus 6 minus 7. My right-hand side hasn't changed. So now I want to start combining my like terms. I've got a positive 6, negative 7. And then over here on the right, I've got my positive 2x, I've got my positive x, and then I've got my positive 2 and my negative 3. So let's go ahead and combine like terms so we can simplify. So on the left, I've got 3x minus 1. On the right, I still need to combine those. Again, positive 2x, positive x, positive 2, and negative 3x. So when I combine those, I get 3x minus 1 equals 3x minus 1. So 3x minus 1 is on the left, and it's on the right. we might be starting to think that something funny is going to happen. Let's just see if I can get my variables together. I have a positive 3x, so I'm going to do the opposite. So I'm going to subtract 3x from both sides. But again, it cancels on the left and it cancels on the right. So I end up with -1 equals -1. Well, yeah, that's always true. -1 always equals -1. So x has an infinite number of solutions again, because I ended up with this statement, always true. So I have an infinite number of solutions. Again, that means I could choose any number, 0, -5, -50, 2/3, 3/5, anything, plug it in for x, and I'll still get a true statement. So let's have you guys do a couple on your own. Oh, let me erase that for you. Number 4 is 5x plus 6 equals 2x plus 8 plus 3x. Number 5 is 13 minus 2x minus 2 equals 2 times the quantity x plus 2 plus 3x. Make sure you do your parentheses first. And number 6 is 4 times the quantity x plus 2 equals 8x plus 2 minus 4x plus 2. So go ahead and pause, solve these on your own. Do the distributive property first, combine like terms, and then we'll check our answers. So for number 4, x has no solution. You should have gotten a funny answer. For number 5, x should equal 1. And then for number 6, x has infinite solutions, so any number you could think of. If you still have questions, go ahead and watch the video again, check out the other resources, or see me or Mr. Ibanez after school. We'll be solving equations like this for a couple of days, so you'll get plenty of chance to practice. Thank you.